Alright guys, welcome to RC Mojo. I finally got to have a good run with the XV-01 the other week, and while the handling is rather good, it seems to be robust enough and is quite entertaining. One thing stood out as something that needed some improvement. Power! Now, considering this will be run off-road and only has small tyres and a fairly low ground clearance, we didn't want anything too silly. Our TT-01 Subaru is quite ballistic with its El Cheapo 9-turn setup, which I'm sure would be fun, but I can't see the car lasting more than 2 minutes with that kind of speed in close proximity to large trees. So we've ended up with this Speed Passion Champion combo set. Nice. Inside is the Competition 3.0S, a basic sensorless motor. In the box you get a nice big sheet of paper with some basic info on a range of Speed Passion motors, nothing too insightful though. The motor itself is a 540 size, so it should fit fairly well in just about any car. The ESC is a Reventon S. It's good for 40 amps, will run censored and sensorless motors. There's loads of accessories available for wireless programming and such, which is quite neat, but not included. In the box is of course the ESC, a packet with some servo tape, heat shrink and a zip tie, a USB lead, the programming box, and there's also some paperwork, instructions and whatnot. The programming box is quite neat. There's a slide out drawer that shows you what the menu options are, so you can't lose the reference sheet. Under the orange sticker of doom there's a USB port, so you can use it as a PC interface. Next to that is the connection to the ESC. The motor leads are for most installs a bit on the long side, except on the XV-01 with its daft layout they're actually a bit too short, but more on that later. The battery connector is a Dean's, which is great. There's a fairly chunky smoothing cap across the battery. Under that is the sensor socket, which has a rubber seal, again good to see. On the other side is the switch, which also has a setup button, so if the ESC is buried you can still get to it. Really neat. The radio connection is on a removable plug too, so a custom length lead would be easy to make. The fan is also removable, but on the XV-01, it being enclosed, it might be very necessary in the summer. And on the bottom is some pre-applied servo tape, something that took me a second or two to figure out. On the back of the motor there are 3 solder posts, fairly common, and the ends of the ESC leads have sockets on, which obviously don't fit. Turns out the solder posts are actually sockets, and can be pulled out to reveal what look a lot like banana plugs embedded in the motor. Very nice. Okay, that's it for the introductions. It's time to get upgrading. Now, since I hope, if you're watching this for some guidance, you put your own XV-01 together yourself. If you did, most of this will be very straightforward. First part is pretty obvious. Remove the electronics lid box, disconnect the ESC from the receiver and motor, and pull it out. Remove the servo side front wheel, and remove the hex and pin so they don't get lost. Remove the foam bumper, keeping the screws somewhere safe. Pop off the servo side front damper, undo the 2 gear cover retaining screws and remove it, fish out the motor wires and undo the motor screws. And it turns out the pinion won't fit through the motor plate, so undo that first, or like me, after. Now remove the motor. You might be able to get it out by turning the steering left, but removing the other wheel will make it easier later, so pop the wheel off and pull out the motor. That's all the stripping we need to do. So now, the fun part. The motor has several pairs of holes, all on the same PCD, so any pair will work, and on this chassis the only real issue might be the connector interfering with the damper, so check clearance as you go. In my case, I'm installing it so the printed logo is visible at the front of the chassis. Use the same screws to fit the motor that we took out earlier. If the screws are very stiff to get in, your motor may be like mine. Whoever spec'd the manufacturing process seems to have painted the motor after tapping the holes, so the threads are full of paint. That, or they use blunt taps. Either way, you can run an M3 screw in, do it up half a turn, back it off a bit and repeat. Keep going until you can see the screw poking out the other end of the hole. A caphead screw is easier to get the torque down. Don't use a tap though, as you'll end up with bits of metal falling into the motor. When it's in, pop the pinion on, getting the teeth lined up with a spur. Then you need to set the mesh. I do it by feel, make sure there's just a little bit of slot between the gears, checking at several points around the gear. Now things get a bit more tricky. If we pop the ESC into its slot, you can see there's a bit of an issue with length. That's just not going to reach. But this ESC has exposed solder points for the motor wires, so all is not lost. We just need some 14 AWG wire and the sockets from the motor. Those who are allergic to soldering should look away. The first job is to remove the wires. You'll need a fairly hefty soldering iron or soldering gun, as we want to keep the heat as local to the wires as we can. Lower power irons will take longer to heat up the joint, and thus the heat will travel to the internal components. Hold the ESC down, heat up the solder blob, and very gently pull the wire until it pops out. I couldn't find a good position to do this in front of the camera, but hopefully you get the idea. Clean out the holes. Some solder wick is ideal. Failing that, use some scrap wire to absorb the excess solder. Cut the new wire roughly to 350mm lengths. If you get a metre of it, cutting it roughly to thirds will be close enough. Remove some of the insulation and tin the end. You only need about 2 or 3mm of exposed wire. Pop it into one of the holes. You might need to wiggle it a bit. The wire should be just slightly proud of the PCB. Hold the ESC down so the wire is held in place, and heat it up with the iron and apply a bit of extra solder. It's not so bad of a process. The only dodgy bit is the proximity to the sensor connector. Of course, you'll need to do that to the other two wires as well, but you should end up with something like this. Now, to install the ESC, peel back the backing and stick it in. But wait, in hindsight, it's a bit early for this. The ESC only just fits under the lid, so I should have checked before sticking it down. I ended up having to reposition it later. Not the end of the world, but not ideal for the servo tape. Anyway, there's a small gap between the gear cover and the damper tower, so you can just about squeeze the 3 motor wires through, making it look nice and tidy. You can also just run them up and over the top, but then you'd have to tie them down with something. More soldering now. Run the wires through the clip and cut them to length. A centimetre of extra is a good idea. Then strip and tin the ends. Clamp one of the sockets in a pair of pliers and put them somewhere stable. Or, if you're like me and you give up finding somewhere stable, just hold on to them. Be very careful you don't slip. You'll need to do all 3. Remember, if the wires are a bit too long, it's not much effort to shorten them, but making them longer, you'll be starting again. Right, here's my final install. The ESC is stuck in as close to the lower left corner as it would go. The motor wires just about fit around the side of the fan. I had a bit of a problem with the capacitor. The stock wire length puts it right under the divider in the lid, so it didn't fit. So I had to replace the wires with some that were a little longer. Not ideal, as shorter is always better. The other option, of course, is to run without the lid, or perhaps cut a hole for it. You'll have to make your own mind up about what you're prepared to do. The switch, of course, is stuck to the top of the servo. The wiring is just about long enough. On the motor connectors, I fitted some black heat shrink. Looks a bit better and will protect the connectors from the odd stone. That's about it for the electronics. So those who react badly to soldering can open your eyes. It's over. The rest is just reassembly and some button pressing. Okay, we'll start with the gear cover. Pop it in and install the 2 screws. Remember, the top screw goes into plastic, so don't overdo it. Pop the damper back on, reinstall the drive pin, hex and wheel on both sides. Slide the foam bumper back over its posts and install the 4 screws. Now, before we put the electronics lid back on, we need to configure the ESC. The default settings will get you going, but if nothing else, it's good to check. Unplug the ESC from the receiver and connect it to the middle connector on the programming box. The white wire goes to the end with the notch. For safety, put the chassis up on a box so the wheels can spin freely. The motor shouldn't spin up, but it's better to take precautions. When it's all safe, connect up the battery and turn on the ESC. Yes, the fan really is that loud. Let me mute it. Right. The display is split in two. The left is the item number and the right is the current setting. To see what you're doing, pull out the drawer with the reference sheet. Number 1 is running mode. You can choose no reverse for club racing or the usual forward and reverse. Number 2 is the cutoff. There's a range of LiPo cutoff values and option 6, which is no protection for NiCad and NiMi. Number 3, dynamic multi-timing system, which is simply the timing advance. Default is 18.75 degrees. We'll need to test run the car to tune that. Number 4, DRSS 3.0, more commonly known as the punch setting. Number 5, percentage braking, basically how strong the brakes are. Again, to set this up, we need the car running. Number 6, percent drag brake. This controls how much the brakes drag at neutral. Useful for racing, not so much for bashing. Number 7, throttle percent reverse. This limits the speed of reverse. Useful as on a lot of wheel radios the trigger doesn't move far for reverse. Reducing the top speed makes the car less sensitive. Number 8, neutral range. If you have a crap radio with a jittery signal or a wobbly trigger, you can set the deadband to compensate. Number 9, overheat protection. You can turn it on or off, but on seems like a good idea. Number 10, the current ESC temperature. Number 11, battery voltage. Not sure what they use for, but 8.3 volts is likely as the battery just came off charge. Number 12, the firmware name, which apparently is NDO. With all the settings checked, we can turn off the ESC, unplug the programmer, reconnect the radio, and give it a test. Turn on your transmitter, turn on the ESC, the fan should start up, and the steering should work. So far, so good. Hold the chassis down and give the throttle a tickle. It should spin right up. Check the direction. If you're on a Futaba radio, the instructions say to reverse the throttle channel. Other than that, if the wheels are spinning the wrong way and you're using a sensorless motor, you can just swap any two of the motor wires and you should be good to go. Now, I still need to set up the ESC, so I need to run it with the lid off, but for the sake of completion I'll put it on now. Because the gubbins are going to be tightly packed, it's a good idea to remove the ESC cover from the lid so we can see inside. Offer the lid up and be extremely careful to avoid pinching any wires. You can use a small screwdriver to hold any wires away from the sides that are trying to escape. When you're sure everything is sitting nicely, pop the 4 screws in, all the while checking to make sure nothing is trying to get out. When they're all in, flip the chassis over and check the battery lead is free to move. Have a look through the top and see if there's anything in the wrong place. If it all looks good, reinstall the cover, and I think we can call it as good as done. The only concern now is, does the ESC have enough ventilation? This time of year there's no worry, but in the summer I reckon it might get a bit hot in there. But you'll have to wait for summer to find out. At this point in the video I would love to show you a bit of running, but it's chucking it down outside. The puddles are slowly merging, so I don't think it'll be running for a few days yet. So here's a clip of the car with the stock motor, but speeded up to simulate the extra power. Thanks for watching, hope you enjoyed. If you did, a thumbs up is always much appreciated. Don't forget we're on Twitter, and every so often we post pics of things that we're working on. And of course, there's always rcmojo.com.